we plotted the signal versus response graph, that is also called dose response graph or curve. Here it is mostly behaving as a normal distribution. So it looks like a normal distribution. So we can say it is quite normal distribution. So it is just input. We have selected, taken x-axis as the input signal, y-axis as the response, and then it behaves like a normal distribution. Next is how the kinetics of fully active proteins are changed after removal of input signal. Here what we have done, after certain time points, that means here we can see the time points are up to 500, and I think we have removed the input signal after 200 time points. Then what happens, just after the removal of input signal, in most of the networks it tries to go back to zero. That means the peak is trying to end up. So that means the activation, there is no more signal. When you remove input signal, there is no more output response at all. But there are some of the networks also which are showing the further increase in the output response, as you can see on the in generation 150 in system 1, system 2, and also in generation 50 in system 1 and system 3. So here again we are going for partially active. This is for fully active, and for partially active it is mostly showing that there is highly transient or fully adapted response. That means the peak is coming very sharp, and then it is immediately trying to go back to zero. So next part is effect of changes in the concentration levels of signaling molecules. Here what I have done is I have tried to allow the change in the concentration of input signal in each generation, concentration, change in the concentration of receptor molecules, and this one is change in the concentration of receptor molecules. And in change, when we are changing the concentration of receptor molecules, it is immediately trying to reach the maximum fitness value, that is 1.0, for the two stronger values